Hello, good to see you back. This week we're going to give you some feedback on last week's assignment again, and therefore we will show you some examples of the students that have done their work over the last week, and I will discuss a specific question at the end of this session. But first I'll give the floor to Tess, who will discuss a few examples of the work that has been done by you.
The first example is from Rana. Rana lives in Lebanon. Since she lives in a temperate climate, Rana's measures were selected in order to limit the use of cooling during the hot summer months, while maximizing solar gains during the winter. As first step, insulation is added to the outside of the building. Together with double glazing, this reduces the transmission losses through the building envelope. To reduce the demand for cooling, Rana created overhangs above the windows. Beside that, vegetation is placed in front of the windows and a green roof is added. Finally, Rana uses cross ventilation. In this climate, cross ventilation can be beneficial when used for summer night cooling. In this way, the fresh night air cools down the building. A more extreme climate is found in Kosovo. This continental climate is characterized by the large temperature differences, varying between minus 27 degrees and plus 39 degrees. In the house of Primessa, the living areas are located on the warm side of the house, while the corridor, kitchen and bathroom are located on the windy and colder north side. Trees are added to weaken this wind. Thereby, the northern side requires a more extensive renovation to lower the heat losses. This will be reduced by replacing the windows with double glazing and by insulating the building envelope from the inside. Beside that, Primessa implemented another measure, a solar chimney. In the top left image, you see how this south-facing chimney is attached to the building. The air in the chimney warms up, creating a stack effect, extracting warm air from the building, while fresh air, outdoor air, is pulled into the building. There are also other ways to reduce the need for cooling. In this climate, movable solar shading is a good option to block the sun in the summer and to allow solar gains during the winter. For the tropical savanna climate of Mozambique, João selected multiple passive cooling measures. In his city, the average temperature is 23 degrees, with limited variation between summer and winter. Vegetation is placed in front of the balconies to provide shading to the balconies and the bedrooms. The other windows are shaded with overhanging structures. Currently, the rooms below the flat roof part of the roof are very warm. Therefore, an additional roof is added to shade this roof. Cross ventilation should be used to ventilate the air cavity between the two roofs. The student also added PV panels to generate electricity. However, this isn't part of this week. The produce step will be discussed in week 5 of the course. Another example of a tropical savanna climate is this building in India. Kedar made a clear section to show the selected measures. The building has large windows on the cooler east side, while small windows are applied on the sunny west facade. As in the previous example, different passive measures to reduce the amount of cooling were taken, as the green roof, overhanging structures, and vegetation cooling. Also, evaporative cooling is used to cool the building. Beside that, the reduction of the cooling demands, the electricity used for lighting is reduced by solar tubes that provide additional light to the ground floor, reflection of daylight by the water feature, and by the use of LED light. Now Andy will show you how to determine the achieved energy savings.
Hello. This week we had a specific question by some of you, how to calculate the possible savings that you proposed by energy saving measures. There's a few steps you have to take then. First, you need to know roughly, of course, what the reference energy use breakdown is. So how much of your energy is related to heat, which may come from different sources, and how much is is used for electricity. Then, of course, you need to know what is the breakdown of the heating energy. So what is used for domestic heating, what is used for hot water, and what is used for cooking, for instance. The breakdown of electricity is also something you need to know. So how much is used for lighting, how much is cooling, and how much is the use of equipment. Finally, you need to estimate the potential savings that you propose with all the measures that you have taken into account with your design this week. Now, there's an option, of course, that you don't know the total energy breakdown, which I hope you don't, but it is possible. Then we have to look at the different climates, and I only took 5 main climates now, but it's just as an estimate to see what might be the division. In that case, I would assume this. So if you have a polar climate, which is a cold climate, colder than temperate. You have a temperate climate, a continental climate, a warm climate, which is also perhaps a Mediterranean climate. And then you have a tropical climate. Then you see that you could divide the demand for energy for heat or electricity according to this graph. So use that to have a sort of an idea of the division between heat and electricity. Next step, of course, is that you think about the breakdown of heat. If you don't know it now, you could use these figures, which are then again to be applied for the different climates. So look at how much you approximately need for heating, for domestic hot water, or for cooking as the main sources of heat in a building. Electricity, same story basically. You look at the different energy users in the building. Most of it is related to lighting, to cooling, or to the use of equipment. And you can use these figures, as stated here, depending on the different climates that you have your building in. And finally, of course, you have to estimate the savings that of the measures you propose to your building. You can assume the following savings. For instance, thermal insulation could help you to save 20 to 50% of your heating demand. And this, of course, depends on how much thermal insulation you can add, the thickness of it, and also, of course, how much of your building is opaque in that sense that this is a part of your envelope that can be insulated. The second, high performance glass, so well insulating glass, which can be double glass or a triple glass even. That also depends, of course, on how many windows do you have and the type of glass you actually choose. Then you can save, for instance, energy for your hot water purposes by using water-saving taps or energy-efficient equipment for that. Thereby you can save on your showering or hot water usage in the building. The last one I want to show is cooking. You can shift from cooking on gas or on wood or on other sources to cooking electrical, which could also be induction cooking. In that sense, of course, you save all the energy used from fuels and it shifts to electricity. So the reduction that you have on heating, you have to add, of course, a little bit on electricity use. Now, if you also want to do a similar exercise for electricity, these are figures you can think of. You could think of changing your lighting. If you have light bulbs right now and you replace them by fluorescent lighting, then you can save approximately half of the energy used. If you do use LED lighting, light emitting diode lighting, then you can save a lot, as you can see here. Of course, it's more expensive, but a lot of energy can be saved for lighting. Shading devices, of course, are important to reduce the upheating of your building and therefore with the artificial cooling you have to install. So think about this figure, and it also depends on how many windows do you have, how is your building oriented. So you have to estimate it a little bit yourself. It's a bit about thinking brightly about it yourself and then using a figure that could be justifiable. The same applies to a green roof. Many of you propose green roofs, which can, of course, limit the temperature going through the roof into the building and thereby saving the cooling. It depends, of course, how many floors you have. If you have more floors, your roof is relatively smaller and then has little influence. But if you have one floor only, then of course it can make a big difference. Estimate it yourself. And finally, of course, there's energy saving equipment. Not just A or A+, can also be A++ or A+++. And this equipment, of course, can save a lot compared to your other devices. And I'm thinking about fridges, freezers, TVs, etc., etc. So if you use those, you can save up to 50% of your electricity use for that part. Now, if you all combine them together, so you calculate the fraction of heating, the savings in heating, and then add up to the savings that you can estimate through electricity use, then you can sort of make an estimation of your total savings by this first step of saving energy. Thank you for your attention. I wish you good luck, and I hope to see you again next week. Bye.